So we're going to talk about musical pitch now, which is sounds and it relates to their frequency. And so some really important things is that we assign these notes different frequencies. So the A is at 440 hertz, meaning the sound repeats itself 440 times in a second. And we mentioned before that to get an octave, if I double it, this goes to 880, that's also an A, but it just is a little bit higher in pitch. If I double it again to 1760, that's also an A, but it's just even higher in pitch. The higher the frequency, the higher the pitch of the sound. But anything that's a double or a half is the same note. And this difference is said to be an octave. Well, an octave jump is usually divided into 12 separate pieces, 12 divisions that are called, they're approximately equal, and they're called semitones. And semitones appear, it's approximately equal on the log scale. And further to that, on an equal tempered scale, where they are all the same, then the semitone is made up of 100 cents. So 100 cents is one semitone. And it turns out that the human ear are only sensitive to about 2 pitches. We can't tell the difference of less than about 2 cents. So approximately 2 cents. So if two sounds are within 2 cents of each other, we can't really tell the difference between them. And so what we want to look at is we want to look at a problem where we're talking about a jump of 1 perfect major third is given a frequency increase of 25%. An equal tempered major third is 400 cents. So the new frequency is equal to the old frequency plus a 0.25 of that frequency, or to 1.25 of that frequency. And so that's how much it increases by if it increases by a perfect major third. Well, we have a formula that tells us that P of F, this is the pitch formula, if we know the frequency, then this is equal to 1200, that's how many cents are in it, of log 2 of F over F naught. So if we want to know what our major increase is here, P of F in this case is P of 1.25 F naught equals 1200 log base 2, 1.25 F naught over F naught. The F naughts go away, and so we end up with 1200 times log base 2 of 1.25. I'm going to use the change of base formula real quick and make this a natural log of 1.25 over the natural log of 2. So I can type this into my calculator. 1200 times 1.25 natural log divided by 2 natural log equals. So this is approximately equal to 386.313 cents. That's what we get out of it using a calculator. Now, we're told that an equal tempered major third is 400 cents. So how close are 386.3, or let's just call it 386, to 400? Well, 400 minus 386 is 14. 14 is much bigger than 2, so it turns out that the ear can pick up the difference between a perfect major third and an equal tempered major third. So we can tell the difference, so it is noticeable on the major third scale, whether we're in equal tempered or if we're a perfect major third.